to, can you start?
Yes, but can you hear me, Professor?
Yes, I can hear.
Okay, I'm thinking that since we have the same people, and I think I will just go to the slide where basically I added more new results to
Okay.
disclose, because previous one I thought that we will have a new people and I will share same thing, but as you know, the same thing it will be.
Okay, it's okay. You can start from the beginning, and you can explain the background information. Yes, please start.
Okay. So I think in the initial presentation, I was discussing basically about what was the importance of human factor study, why we should study human factor and why it is important, because we were discussing about that the idea of studying human factors or human movements it was started early with the intention to be support humans in terms of like in the medical field, like for example rehabilitation, gait analysis. Then it moved towards surveillance, because to observe human behavior. Later it moves to the robotics, to understanding human basically humanoid robot synthesis, motion synthesis. And then recently people try to understand for service robot applications, or for example understanding the movement mechanics of humans or kinematic configuration of human movements, to understand their actions or activity categories or their kind of specific kinematic postures for different kind of human assisting robotics applications, or like a different kind of, even in the medical also people now study the human body movements more, like this is. So previous lecture I was discussing, previous seminar I was discussing about this important, and we were discussing that what we have done so far. So I was talking about why we study human factor. This was I discussed what is the motivation behind why we should study still collections data, because to understand the human movements we need to have a data, because data is a very important things. And now data can be, it was started from the very beginning or initial period, that we start with a wire-based sensors. That means the sensors which were placed in the human body. From that, then we move to the monocular vision, or like a normal camera vision, and then we move to the high definition camera, stereo vision. Then we move to, nowadays it's called RGBD sensor, which is the part of depth sensor, which allow to collect the human body joints, or in software terminology we say it's skeleton joints. These are the things, the different process. Then I will show you, like as you see that these are the skeleton, but the most important thing which I said, these are the process. Initially, when we used to extract the human features right now based on the image, we used to just detect the human object on the image, right? And there was different approach. There was classical approach, even they used to use neural network approach, but not that deep networks to extract those images. So they had their own classical approach, they have deep network approach, but it was used to work on image. Right now, if you look at the second part, then we move when the new generation RGBD sensor came into the market, we make this processing part more easier, because then we don't have to process all the background. If we need it, we process, but mostly we used to focus on the human body, and the skeleton joint was the most efficient way to understand the body movement mechanics, because it is only focused on the joint, human movement joints, rather than the whole body part, like in every skin and all this. And also it reduce the process of the whole image, like means all their color pixels and all these things. So these are the methods we say. Then we was talking about that example data, how we did this part. This part we also talk about. Okay, this part I would like to give a little bit highlight what we talked. The idea of this is that whenever we collect data, irrespective of it's a human data, any kind of data, when you collect with the sensors, whether it's a wireless sensor or a wire-based sensor, we always receive some noise. This is very rarely equipments or instruments that offer noise-free data. because we always receive noise because of our environmental issues, because environment is totally different, and it might have a different characteristic of the environment that may have noise, or that can also produce noise. So we cannot always think or always expect that our data will always have a noise-free data, because it is not always true. I'm not saying that. So that's why before we apply or before we use those data to the neural networks, if I say in a simple terms, neural networks, we always do the initial thing to check if our data is noise-free. Because when we use the noisy data, the neural network might, or any kind of machine learning or AI algorithm, may offer you or may provide you with a false positive results. So that could be very not useful, especially when we are using in real-time application. So at least I'm not saying that we do, because in real-time application sometimes it's difficult to do in real-time noise removing processing, but it is doable. I'm not saying it is not doable, but sometimes it's a time consuming. So at least what we can do is, during the training of the model, or define the model and training and data, we always try to make the data as much as possible noise free, so that we can have the model will more accurate to identify when or classify any kind of postures or about human movements in the real-time application. This is one. Then we are using different kind of neural network model, which we discussed. This is, I think last time one student were asking. So this is the model. But today I will be discussing more about this model, this part. So this is the most interesting model. Now, this is the very traditional model. It's called self-organization map. The name itself says that it's an unsupervised model. So what it says that I have the knowledge, that I will use my own knowledge instead of humans' intervention, and I will define, or I will categorize what kind of actions, what kind of postures is. So it means I'm grouping, and the groupings that can be done they have their methodology. So when I talk about the methodology, these kind of neural networks are not deep. That means it doesn't have multiple layer. It has input layer. It has one calculation layer. I call it calculation, but it can have, people may say any kind of layers, like it can have, and that calculation can be defined on distance calculation, neighborhood functions or something, and then is giving the output network, right? Output. So here, what is we are saving is the deep network, which means time consuming. That means that will take lots of time if I go to this. Okay, the time consuming part. And also we can make the network, the training process much faster, because it doesn't have to go to each layer so and much. And also it is useful in the real-time application. Why I want to pay significant attention, that whenever we select a work, we have to figure it out, what is the target goal of our work. Either we are doing in the theoretical point of view, or for example, computer science point of view, or we want to do mechanical, robotics, and or real-time point of view. Because in theoretical and software development point of view, it's good to have a deep network, because then you focus on basically how you can improve the model in terms of accuracy. That means how much accurate it can classify. Okay, so you don't bother about that term, how big the model is, what is the computational complexity, because you are working with a system where you have more powerful resources, and that resources will be enough to train or use data or use a very big model. But imagine when you want to apply, when your target goal is to apply on a real-time systems. I'm not saying it's not only limited to robotic system. It can be any kind of platform, machine platform, where you cannot expect the powerful resources. The machine also has a limitation because of its size, because of its capabilities. So we need to come up with a solution that is not deep network, that is not taking or consuming the time complexity, and efficiently deliver the results what is expected. Of course, I'm not saying that the high level of accuracy, which we are always considered when you're talking about software point of view. Okay, because there we have a powerful resources. Here we don't have. So this is the main reason of this, that we develop this model. Very interesting part of this model is this is the one of the kind of model. Maybe somebody did it before, but this is the one of the kind of model that can be used into dual mode. When I say dual mode, it means this model which can be used for classification, that means in a supervised nature. When I say supervised, that means human intervention is needed. That means you need to annotate, or you need to label the data, train or to classify. Or second mode, it has the capabilities that you can do without human intervention. That means you can do clustering. So this model is designed in such a way that initially when we want to train, we will train in an unsupervised way. That means the human intervention, the handmade craft feature will be not needed. That means, which is I call it as a annotation or labeling, will not be needed. We will be train the model based on without annotation. So what happened? So, but there will be a questions now. Every model need input and output. This is should be defined by the user. And now here, what is new? We define the user, the input data, because we know what is our number of joints in the body and their three-dimensional coordinate system. So we selected, for example, 19 joints, and 19 times 3 is a 57. So we consider 57 input. But here is the tricky part, that we did not define any output layer, because generally a model need output and input. Here we did that the model will be trained with as much as neuron based on the input data. Okay, so what will be the advantage? What will be the advantage of this model is that user is not defining the number of neurons will be at the output. So what will happen? It will be calculated based on the input samples. It will create as much as neuron based on its characteristic, and later we can use these weights of neurons, that it will calculate it based on the number of sample, and then we can use another two kind of algorithms for what purpose we want to use. We want to use for classification, or we want to use for clustering. So what happened is a kind of, which is called a model, which is basically, there is a term called transfer learning. Transfer learning says that if someone is developed a model and they train this model based on million of data and they share with the public, and the public will take the model and their weights only. Then they cut. That cut means they remove the top layer, which is the first layer, and they remove the last layer, which is the output layer. But in between, this weight is always staying there. And the input and output layer is why they changes, because it's based on the task you are taking, because your input can be different, your output, expected output can be different. So this is a kind of that idea where, of course, we have a strict input like a 57, but output is not defined. Output can be, instead of output, we can take the weights, and then we can have our own algorithms, that is for either it is classification or whether it is for the purpose of clustering. Like as you can see, for classification, we did with a algorithm called labeling map. And for clustering, we did the algorithm for k-means. And what happened, this labeling map will need label. So user will define the label. They will take the weights of the train weights, these weights, the winning neurons, which is the weights. And they will, in the labeling map, then you define how many number of labels. That means how many number of output you want to give. And then this label will try to concentrate. Concentrate means, that means minimize that huge number of weights and to only the expected number of labels. So what will happen? So it will reduce. So that means it will reduce our work during the training process, because if we have to train every time with a different level, or for clustering purpose different, for classification purpose different, that means how many way we have to increase the time complexity. First of all, we have to check with different number of levels. Then we have to check for the classification another model, then for clustering another model. Here we don't have to do that. And for this purpose, we will show you here. before I go this one, I will show. So look here. In a normal model, what will happen? We give the number of training sample plus, of course, weight plus also k number of cluster. That means we are defining the cluster, like whether it's 5, 6, 7, or like for 10. What will happen? So every time it go through, if we initially we check with, okay, our number of output, expected output is 5. So we have to train the entire model again with the 5 output. It is not satisfied, we go for 6. We have to train. This is the normal strategy when we're talking. But in our case, look here, we just have trained only with the data without giving any output. Like here, this part, if I look at this part, and you train only once. Here you have to train multiple times for the multiple output. Here you train the ones. And then the plus sign, you see that here is a times, here is a plus. Here we use a k-means algorithm, and in the k-means algorithm, then we can give 5 or 6 or 7. So what will happen? Here training with, because here we have 200,000 samples, for example. So 200,000 samples training 3 different output 3 times, it will be more than here. We just only train only one time, and then we use the k-means cluster to reduce the high. Maybe here we have a huge number of neurons because here we don't define the output. So output is defining based on the input sample. But here we can define what is the k-means with the output, 5, 6, or 7. So please listen carefully. Here in the model itself, we are defining the output. Here we are not defining the output. Here the output is defining some extra algorithm, the k-means or labeling map, and we are defining. So in this case, the training will be, you have to repeat the entire data set of training based on what is the output you given. Here you don't have to train the entire data set. You just train only the k-means with the different settings. Settings means different output. So we are reducing the basically the idea of huge data training. Okay, we're doing only one time instead of 3 times for this example. Now another thing, what is the advantage? When you don't define for example, a number of neurons in the output, we are reducing the outliers. Because what happened, if you, for example, if you have like a defined the output layer of this network is, for example, only 2 kind of neurons. So what can happen is that some kind of output outlier belongs to one of this cluster, which is maybe not a part of this clusters, because here we define the output, because our output should be only 2, means somehow I have to adjust this outlier into 2. But since in our model, this is the uniqueness of our model, we are not defining any number of neurons in the, at least during the training process. So what happened? We are defining as much as possible neurons, like, based on the. So what happened? Some of the outlier, which will be close to one of these neurons, will go to that neuron, and it will not affect the entire part. As you can see, we have neuron 1, neuron 2, neuron 3 here. So 5, 6, 7. Here we have cluster 1, cluster 2, right? And so maybe this one belongs to only N3, okay? And of course, they are all similar characteristic, but in the similar also there might be some difference. Like for example, also walking. For example, I walk, okay? From one camera because we are using 2 view of camera. One camera view work has a different way of geometrical view. Another camera, okay, but they both are walking, but with a little bit different features, right? So outlier will not affect the whole walking. Outlier maybe belongs to only one view of, for example, this is just an example, please careful, that only one view of walking, that the outlier belongs to that. So it will not affect the entire walking, which is come from one view and second view, first view, second view, because both are walking, but the outlier belongs to, for example, the second view of camera. So in this way, what we are doing is we are reducing the how to say potential danger of outlier that can affect the cluster. So what will happen? So it will happen more layer on more neurons, and then we can use any kind of k-means or labeling app to reduce. Then from this one, right now we have 4 neurons, then we may reduce from 4 neurons to only 1 neurons. So what will happen? So those outliers will be either removed or without, or will be just somehow adjust in between that in this. So this is the thing is, instead of, let's for example, we will remove this one, the outlier, instead of we are considering them in this scenario. So the idea is that of this work, of this model, that, or the uniqueness of this model is that how to reduce this outlier that can make a false positive in our models, that which is could be a potential dangers like this. This is the idea. So this part is like, as you can see, this is your ground to data, right? Which is given label, as you can see, the data. And we have our proposal, we compare with the many different state of the art. If you look at, we define only some area to show the similarity. This is the ground truth. And also this is our model that we are reaching very similar. Of course, as you can see, I would like to very carefully focus here, this part. You see little bit, this part is little bit dark violet. This part has no violet color. This part is little bit changing. As you can see, this part is orange. So there are some errors still, because you know that if we cannot expect a neural network model to give 100% accuracy. When it says 100% accuracy, it is obvious there is a false positive. So there must be always. So here, but when you reach much more, here you can see this part is similar, but here it is very bad quality, right? Here we have much more worst quality. Look here and compare. Look here, this part, much more worst quality, this part. So we can see the difference. So here we have to see. Now this part of the result is the classification, because since I said that our model can be used in a dual mode, either classification we can use with the labeling map algorithm. This labeling map algorithm is the purpose of that we use label. That's why it's called labeling map algorithm. We use label for, and it is for classification, not for clustering, where you don't give the label. As you can see, this part, you have the label. If I see, you have all the label, and you can see that they are changing the label class. Okay, now what happened? Now the second mode, where is this clustering? Now in the second mode clustering, we use the k-means, but it is also improved k-means, because we want to calculate the cluster based on like a basically by choosing by itself. We give the range, like for example 5 to 25, and we ask between this range, find out the most appropriate number of cluster that will fit with this data. And this, it's calculated, like for example in our work, that only 14 cluster is fitting with the data, and this like, and as you can see that it automatically check the cluster based on the data. So previous one, the demonstration which I shows is about classification, that means about supervised. Here it is unsupervised. Now the question is, this is what we discuss about the collaborative work, that means which we have been doing for last few months, and like also we are collaborating for last 2 years. Like, okay, now what is my purpose to be here? My purpose as a visiting scholar to here, that how we can expand this work. Now to be expand this work, it has 3 categories which I was written in the proposal. First, we want to expand the data, because it is obvious that we cannot disclose a model, or we cannot confirm a model just on a few activities, like or only 20 activities. We have to have more diverse data, more diverse kind of postures that our model can identify and model can train off, because this is obvious. Publicly available data has also more data, because this is the more diverse, the more data is a more better result. Then we have to process those similar, remove the joints and all this, which we did. And third, analyze the developed model based on the new data and its general ability. So I will tell you, right? So we, for this purpose, what our main goal was, along with doctoral students, Dr. Hishin, we discussed that we have to record 10 activities that includes only new postures that should not repeat it as much as possible the previous postures. Like, of course, there might be some repetition, but minimize those repetition and focus on totally new postures. So for that purpose, we have these 10 activities, which belongs to some different postures and different activity. But these 3 points, which I like to be very carefully, or I like to press significant attention, is that we keep the same geometrical setup, we keep the same idea of recording 3 subject 12 times and 2 views, because we want to keep the data structure similar, because we cannot do the different data structure. Previous 20 activities which we recorded is different, and now 10 activity will be different. No, we want to keep the geometrical and the setup similar. Only the activity recording or the type of activities and the posture should be different. Now, these are the list of postures, new postures, right? For those activity we have, previously we have a different kind of postures, like which I would like to show you. Just a second. Oh, no, sorry. It should be here. Here, we have this kind of previous postures. These are the 19 different postures, like collecting, eating, picking, like this one. So in this work, we want to have different postures. Now we have extend hands, hand shaking, hand waving, chairs, clean floor, yoga, hand on the chest, kicking, waist bending, climbing, squat, and so we want to have a different postures. Now we have 12 postures. I give you example here. One of the example here. Only few 9 example, like you say hand shaking, climbing, yoga pose, hair brushing, then waving hands, chairs, cleaning, squatting, and picking up, bending chest. Of course, we have more postures, which I did not want to disclose here because, but I disclose in the table itself. But I would like to I would like to also at the same time place significant attention. These postures are very subjective because this is based on my idea, okay, that these are the postures. For example, another person, it might have more postures or less postures because according to his or her own subjective mind. So that's why we say that why we should focus on unsupervised learning. 2 things. The reason is unsupervised learning reduce the time cost of labeling because you need to invest lots of time to label the data. And also it is also reduce the possibility of subjective labeling. That means it's a subjective to the human state of mind and people's own view. So this is why nowadays our work is pushed or placed towards the unsupervised network. Here, then the third part, which we want to discuss is third part, analyze the developed model on new data and generalizability. So how we did that? We compare. So comparison is, if you look at the comparison, this is the different posture possibility, which is the model is trained on. Now, please carefully remember, this model is trained on our data, which we recorded, like 20 different activities and 19 different postures. Okay, that is the model train win. This is our data ground truth. Then we select one of the record that which was not trained, of course, which was not trained, but has the similar sequences or similar kind of postures that has been trained with the model. Okay, train the model. And we took one of the whole sequence of the activity, which has the very similar actions that belongs to this trained model. And then we check our method and the basic method, like which is self-organization map, because our is the little bit changed, improved, or we have the new idea of dual mode. And we figure it out. Look at here. We have only 2 misclassification compared to ground truth, but here we have more misclassification. So ideal. Now this part, if you look, this is totally on the new activity, which belongs to new postures, right? Totally new postures. But in the new activity, we have quite sometimes some number of frame has similar postures. Like, for example, if we are coming to each other to handshake, at least the walking postures is there, exist, which is in our previous model exist walking. If you look at here, where is walking? Here is we have walking. So here we have seen that we have the walking postures, but there are some places which also consider as a misclassification, like here. Here is considered as a like a standing, because there is some because this is also the factor of the viewpoint. Like, sometimes what happened, turning around, like sometimes there is some scenario where we are, as you can see here, turning front, like we are doing some activity, like we are doing walking or some activity, and the end of the activity we move our body, turn around and look to the camera. So in this camera, since we have two viewpoint, turning around is the activities or the actions is turning around, but for some camera it is standing, because I am in this camera standing, then I'm moving. For this camera I'm standing, like it's not, I'm not walking or doing something, I'm just standing. It's just a camera viewpoint, but actually I'm doing turn around, because if we have a multiple camera, for this camera I'm standing, for this camera I'm standing when I rotate, for this camera I'm standing when I'm rotating. But here also there are totally new postures, some kind of new, some is identified as a walking and some are not identified. Some are like identified, like as you can see that placing, but it is not placing. Some are identified as a, like for example, eating, it is not eating. So when you have totally not a new postures, so what the model is trying to do, because in this model, we did not add another class called unknown class. Okay, since the model doesn't have the unknown class, that's why it is not able to categorize this clustering as an unknown class. It is categorized some random class. And why random class? I would like to place significant attention here. Random class means some of the body part might be similar for this action with, for example, eating actions or something. Some of the body part, either lower part of the body or one hand. So it is matching with that part of the body and it is considered about the whole actions, which is not true. So this is what we need to, will be future work, that we need to disclose, check this model towards the unknown class, and then we will be in future, we will be how to identify this unknown class and how to reuse this unknown class to a new actions so that it can train. So this is what. Another thing is important is the general ability. When we see the unknown class, how we identify the unknown class. So here it is. Like, as you can see, like when we have the average class, which is trained and which is known by the model, that because this model is evaluate the similarity based on the distance calculations. Because as I said, this model has only input in the one layer, which is calculated distance and neighborhood function, and the final layer. And here we are giving the distance. Like when it is a known class, the distance is very less because it's a known. But when it is an unknown class, you see that the distance calculation is always too high. Like compare here, 0.27 is 0.649. And these are the two different whole activity we just check to compare whether how much similarity is there. Okay, and that's why I said that the angular distance for each group cluster calculated and sorted in each test samples. This is how we are basically talking about the similarity and also the idea of similar postures and non-similar postures. So this is the basically so this three part was done during my stay. Of course, but this was done in the last only two weeks. Initially, I would like to say the initial part of our work was that we focus. I think this part I already showed, but here I added one more thing, that what we did at the, now may ask what you did at the beginning of the time. The first few weeks, 3 weeks, I was focused on two things. We submitted a paper to this robotics and autonomous later, that is one of the top second journal in robotics. That is, we was working on this paper to improve the result and quality. And the second thing that we focused on in my first 2-3 weeks time, that a joint research proposal where Professor Matsumaru will be basically as a mentor. And it's like a joint where my responsibility to create a lab with a collaboration with an international expert who can overlook the development of the new lab, and to hire new people from the different country to do some research. And the research is, of course, the research will be similar point of same area of research, but the main goal of this is not only to develop your new team, but also under the supervision of international experts, so that you can create an international environment over the cross-border collaborations. We create a budget of 200,000 USD dollar, which is like a overall, and we will see that whether we do, because it has two stage. First stage is they will check the effective of this proposed method, whether it is usefulness, whether it will be usually doable, practical applicability, and then it will be to deliver a presentation to convince them that why this research is important and how it will help to the society and all the practical application. Of course, this part is the collaboration effort, what we result. This is I already disclosed last time. This part I also already disclosed last time, and this part. So far as of now, with this in this final presentation, basically I would like wanted to focus on this part of the work, like this basically this part. This is model. This part of the work was I wanted to discuss, because why I want to place significant attention of this model, because this is the one of the model we believe, we don't know yet what is our reviewer says, but we believe it has uniqueness, that it can be used for dual mode, and that is a very unique way of develop a model, not only just make it very strict to only one kind of working, but instead of that, we are making it more flexibility in terms of choice of selection. Yeah, what selection of and area of research. That means whether you do want to do supervised model or we want to do clustering. So this model will offer this flexibility and the mode. So for all, this is for me at the moment. Thank you very much. So I would like to finish with this way. Final. Sorry. Thank you. If you have any questions, please do ask.
Thank you. Thank you for your talk. Yes. Hi, Wei Liang. How are you? How are you today? Thank you for attending this talk. Hello?
me?
You well? Thank
Yes,
you.
I'm fine. Yes.
Yes. And maybe you are first time to watch Dr. Dutta's talk.
Yes.
So therefore, it's a little bit difficult for you to understand for the first time. So you may be able to ask the unknown part or unclear part in his talk. Yes, especially about the self-organizing map. Maybe. Do you have some question about it?
Maybe my question is the unsupervised for different pose detection.
Yes.
Yes. So how to do you have some good idea to cluster the different pose in the feature space by the unsupervised learning?
Unsupervised learning for cluster the different pose, right?
Yes.
Yeah, so in unsupervised clustering, when you talk about any kind of unsupervised clustering, they are calculated based on a different principle. Most common principle is that they want to, they go by frame, and they calculate distance, and in their methodology, they calculate distance, and they check the similarities between first postures, they give one cluster, okay, name immediately, okay?
Yes.
And then the second postures, they check the similarity between the previous postures. And now the similarity calculated based on distance or different method. If the distance is less, which means it belongs to the same posture. So they take that postures belongs to the class 1. That means first frame class 1, second frame class 1 like this. And then you go further and further, where they found when the distance, for example, I'm giving you an example. Sometimes they calculate based on distance. When they say that it doesn't belong to this distance, it is totally more than that, then it also, and this distance can be based on calculated different distance approach. You have Gaussian distribution, you have Euclidean distance, then, of course, there is a distribution. Then you have distance, Euclidean, cosine, different kind of distance, right?
Yes.
So when it's not matching that distance, the previous one, it thinks that it is another kind of postures or another class. Then it gives the class B. Then it goes for the next frame. It check whether it belongs to the class B or class A, based on the distance calculations, right? Then it give the, if it is belong to class B, then it will keep the name as a class B. Or if it belongs to class A, then it will give the class A, like that. So basically, if you look at any kind of clustering algorithm, they always have, I'm not talking about the deep clustering algorithm because they are based on neural network. I'm talking about traditional and more often used is basically based on distance calculation or some kind of distribution functions they used to define. So similar, they check the similarity for each frame and compare. That is how do the clustering.
So you know that the video records in the pose, yes, and if you have different, if you change the pose between two frames, how to justify the two categories for the two pose? Yes.
No, in this case, like for example, if you change the two frame, of course, it will be calculated the distance calculations, right? So there will be different distance, and it will be belongs to which distance is which class it belongs to, because this is the part of this distance calculation and different kind of weight distributions. They will do basically by themselves, so they calculate based on that similarity. It doesn't matter whether you suddenly can change in the next frame some totally different postures, right?
Yes, yes.
Yeah, it doesn't matter. If the next frame is totally different postures, it will be obviously it will not match on previous two class, right? Because their distance will be totally different, right?
Yes.
So if they are totally different distance, so it will be obviously considered as that it doesn't matching with class A or class B. So it will be totally different. So it means for them it's a new.
Okay, okay. Okay, thank you. Thank you, thank you.
Especially for the usage for the unsupervised learning. What is the important point for considering about the unsupervised part, clustering part? Vivek, can you explain more in detail about it?
So clustering part in unsupervised method is that we have to define a proper appropriate matrix, like not matrix, evaluation matrix, but design method. That the idea is that clustering is that how much it has capabilities to distinguish or grouping the features into a class based on their own the model capabilities. That means if I say model capabilities, that means model idea, like model, what is the efficiency of the model that can grouping those data into a group in a part of each group. And that can be defined based on how you define what method you define into the design of the algorithm. Here we are not talking about the parameter. Here we are not talking about the how many layers, but here we're talking about what kind of methods, like a distance or distribution, or there might be some other methods also. So it's depend on what methods, because this similarity will be calculated based on those methods.
Okay. Radian, do you have more question about this unsupervised treatment? Radian, yeah.
Oh, okay. I don't have more questions. Yes.
Okay. Yes. Yixing, can you provide the additional something for that? Self-organized map and the unsupervised part.
Yeah, I think I don't have question about it.
Yeah. No question about the more additional explanation or some additional comment.
Additional explanation.
Mm.
Yeah, I think because for the unsupervised this task, in fact, there will be many different principal solutions. So here we only explore the one kind of solution called the self-organizing map. And the advantage of this is it based on, I think advantage of this is only one training. It can both used for unsupervised clustering and also can be used for classification task by the post labeling. So it will be something significant. It's because for to this kind of proposal, only one training can be achieved. So this I think is the most significant part. Yeah.
Vivek, can you provide some the appropriate skeletal structure in your slide?
Skeleton structure, right?
Skeleton structure or the algorithm flow chart or something about
Algorithm flow chart. Wait a second. I think. Okay. So I will just a second. Yeah. Just wait a second. Yes, we have right now. I will just. So this is the paper which I would like to share. Where is the full view? Just a second.
This is under review now.
Yeah, this is under review. So I would like to say, if you look at this one, this idea of calculating this, this part. So in the labeling map, so we have this algorithm for the labeling map, the construction of the labeling map, how we did that. So so here we have, like, for example, we define the label. Of course, we have training data, but also we have to give the ground truth label assigned to the training data. But also then the idea of this one is to reduce this huge number of neurons to the number of neurons and matching with the label map, which is we define to the training data and the winning neurons, as you can see here, like labeling map. And for those 10, defining the winning neuron 10 stack as an index. And then they matching these winning neurons with this training labeling map. Of course, here we are giving to testing with the training data because it's the label. So it means what is defined in the training label map, training data, right, Kishan? And with the training. So that's why then you go by loop for data sample, determine the winning neuron, train in the stack in index, and put the list of the labeling map. And this is how we calculate. This is the one part for that. And then we are going to another one. This is the clustering. Clustering one is of course based on the distance calculations. This, as I said, that we are given of the distance, and of course we are given the number of desired clusters. The number of desired clusters means, as I said, I was giving example. So here we don't have to train the entire model with the different cluster, but we just have the weight. We take the weights, as you said, that we take the neurons from the coherent layer with the vectorized the weights. So this is, we take the only weights, and then we choose the number of clusters, like how many clusters, and we try to reduce those from the weight, which is might be huge number of neurons, to that desired number of cluster. And you check on the testing data, label by label and label by, as you said, the number of iteration and threshold. And this is the whole algorithm process. Here, of course, we have calculated the center distance and all these things. This is the process of this part is a little bit more complex compared to the labeling map, because here we are doing totally unsupervised way. So we use our different approach. Of course, we use centroid and all this because this is the part of k-means algorithm.
Okay.
But this k-means algorithm is a little bit different.
Okay, good. But K-mean algorithm needs the number of clusters. This is necessary to
No,
know.
but in this K-means algorithm, we did not define the exact number of cluster. Instead, we define the range. Like we have defined the range between 5 to 25, and this K-means actually selected by itself between this range what is the best suitable cluster.
Okay.
The possible. Like here, if you go to the paper, it is written here. This is the modified K-means cluster, which is the group the neurons in the coherent layer, right? Here we actually for each number of K in this the average angular, and here we define the K distance. I would like to show you where we define the number of K range here. Where is the, wait a second. Oh, here, sorry, here. Result, okay. If you go to this paper, okay, just a second here. We give the this clustering result. When you define this one, we give from 5 to 25, and we found the minimum distance because here we want to calculate. Here also we kind of calculate distance, and we found the minimum distance is at 14. In labeling map, when you define the subjective way in the human point of view, our point of view, we know that it's a 19 postures. But K-means algorithm, which it automatically detected based on the characteristic of the or similarity of the features, what William was asking, how you define. So look, the K-means itself from the huge number of neurons, because our train has a huge number of neurons, the K-means automatically define that 14. Of course, here also as a human, we give the range, but we did not give the exact number. The K-mean itself calculated exact number is 14. But in this level here, this part, we define the exact number of level. That means it's the 19 levels. This part of algorithm. Here we did not define. It is automatically decided, and as you can see, it automatically decides the clusters, 14 clusters, and what are the 14 different clusters, it's detected by it. So this is the difference, the modified difference. Even in the K-means, like a normal K-means algorithm, we also define as a user that how many clusters. But this is since it's a modified K-means cluster, where we did not define the exact number of clusters, but we define the range. And we ask the K-means to find the most suitable. But that is also a very tricky part, because if you don't define the right range, then K-means can also give you a wrong result. Of course, there also you need a human intervention, but not exactly. That is not very subjective. That is not giving that I'm thinking 19 postures, but maybe another person may think it's 25 postures. So it will be human subjective. But here it is not human subjective. So it is like the model subjective. That model is calculated by. But of course, we are giving the range.
Okay. Range is given, but it means the maximum number of cluster is given to this, and then the K-means result is selected automatically the appropriate number of clusters. Yes.
Yes, absolutely.
Thank you. William, do you have some more question about it?
Oh, okay. I don't have more questions.
Okay.
Okay.
Yes.
Thank you.
Thank you. じゃあ、it's okay. Datta-san, finally you have to say some the closing remarks about your.
Yeah. So
Please turn on. Yes.
So first of all, I'm always grateful that this is my second visit, and to Professor Matsumaru and Professor Matsumaru, Biorobotics and Human Mechatronics Lab, because this is the big opportunity, and I would say as a young researchers, to have a international and cross-border collaborations. Why I say that, and it is for the new students or any kind of student, you need to have a credibility or have this attitude to learn from different environment, because everybody is different, every culture is different, so every society and their working culture. So we need to have the idea or have the acceptance or attitude towards to observe and learn from something. So this kind of collaboration has given me opportunity not only to learn something new and also to get different viewpoints. That means it is always good to have a different viewpoints, because you have a different knowledge, different idea, and sometimes it will give you a multidisciplinary idea. So you can come up with a new knowledge or new research idea. Otherwise, we will be, or me will be limited to my discipline, and I will be never explore the other discipline and other research idea. So that's why cross-border collaboration is important. And because of my previous experience, and also most important thing is, this is what is the most important thing is that how you continue this collaboration. Not only just visit and then you forget, but you have to keep in touch and you have to put also effort. So it is from effort from both sides. So, and that is also useful, because if you keep continuing this collaboration, doesn't matter in what way, you can keep in a writing proposal, paper, or in a just supporting during the scientific research. You don't need any other way. It will also open a door, because of my previous collaboration or previous research stay here, I continue for next 1 year, 2 years, and that give me opportunity to come here. And this time I come from the Waseda University, they from their own fellowship program. So, and also I have the opportunity to apply JSPS, also our lab tech, this is which I told you. So continue collaboration is very important, and effort. Not only taking view from different people, but how much you want to push yourself to keep in contact, keep in doing research. Because this will, of course, if somebody wants to stay in academic people, even in the industry also, it is always useful. Is the most important is not only building the bridge, but how stable is the bridge. That is the most important. You can make the bridge easily, but if the construction of the bridge is not a good quality, it will be broken. But so that's why is the stability of the bridge. So how much the bridge can stand alone for as long as possible, and that is useful. Then only you can use this for the different purpose. So I'm always thankful to not only Professor Matsumaru and also Hishin, and also the Waseda University, so for the giving me the opportunity. And I think within this opportunity, I also had the opportunity to connect many professors from the Waseda, and also Professor Matsumaru and Hishin for doctoral student, from here to my university professor. So it's now from 2% it becoming 5 or 6% collaboration and known person. So this is what I would like to thank you again, and I like to say actually, and thank you again for giving me this opportunity.
Thank you for your closing talks. And then the next time, not only this kind of the periodic tentative encounter, but also we should continue to extend this collaborative works. And then the next time we will visit to the Warsaw, and also the William, Penchens, if you have some chance, please visit Warsaw, and maybe the Vivek will welcome you. Yes. Yes. Yeah. Thank you. That's all for today. Thank you for your talking. See you next time. Bye bye. See you.
See you. Bye.